and welcome to this Substation Saturday webinar series from Scope. This is our fourth edition of this particular webinar series, and today we are going to talk about one of the important topics, that is partial discharge related products, and that too we are going to focus more on the portable products that we have on offer. First and foremost, let me express my sincere thanks to you for joining this particular session by taking time out from your busy schedule. I sincerely hope that all of you, including your near and dear ones, are safe and sound amidst this raging pandemic of COVID. These are difficult times for all of us, and we all hope that this will get over sooner than the later. Friends, my name is Balasaheb Doifode. I am CEO Scope T&M Private Limited. Today we are going to talk about a range of partial discharge products which Scope is offering to you. I need not spend more time in elaborating what is Scope. Many of you are repeat joinee for this particular webinar series and you are aware what is Scope. Let me introduce you more about our partner company, who is the OEM for this partial discharge range of products, and it is DIMRUS Power Diagnostic Solutions from Russia. Now, DIMRUS is a pioneer company in the partial discharge solutions. This is a 25-year-old company, and it is dedicatedly working only in the domain of partial discharge. Till now, they had developed more than 35 number of products for the partial discharge measurement, detection, monitoring, and they have an entire range of products ranging from a simple handheld surveyor kind of a product to a full-fledged 24/7 partial discharge monitoring system for the entire substation, a GIS or a transformer. They are making partial discharge instruments for all type of measurement principles, because when it comes to partial discharge, you might be aware that there are different principles like the measurement based on the acoustic, measurement based on the RF or HF, measurement based on UHF, measurement based on TEV. So DIMRUS has a product for each of these measuring principles. In today's session, we will understand that each of these measurement principle is suitable for certain set of applications, and that is where that particular product is supposed to be used or is more optimally usable. And that's why this DIMRUS has a range of products which will cover all your application variety. DIMRUS, more than a commercial business minded company, it's more of a technocrats company. The chief of the company himself is a technocrat, a doctor, a professor, who is basically more like a professor of a university than a managing director of a company, Mr. Valery Rousseau. The entire approach of the company has been strongly founded with the academic roots that they have. The company is based in a place called as Perm in Russia, a very cold place for people like us. The company is a very popular company, not only in Russia, but almost in 50 other countries where they are doing the business, especially throughout the Europe. The company also holds an annual conference, which will be held down the line after a couple of months, hoping that the corona situation improves. But then they are conducting an annual conference, which is attended by the organizations, the people from the academic background, the other fellow manufacturers of the competitors of the partial discharge products from all around the globe. And people look forward to attending this particular conference, which is arranged by DIMRUS, so that they get more insights into the activities which are happening in the field of partial discharge, not only in Europe but globally. Scope has joined hand with this company since last 4 years. Our association with this company is very thick. Apart from the routine annual visits that they make in India or we make to Russia, there are quarterly interactions taking place in order to enhance the technical competency of our team in India and in order to ensure that whatever support is required by the end customer here is provided capably. Scope, as all of you know, is known for its customer focus and impeccable after-sales service support. All the products that we offer here, even though they are from our foreign manufacturer, the complete after-sales service, the calibration support is taken care by Scope locally. And that's why our customers keep trust on us when it comes to buying the products which are offered by Scope. And we value this particular trust, and it is always our constant endeavor to ensure that we are, हम उस ट्रस्ट के ऊपर खरे उतरेंगे. ये हमेशा हमारी कोशिश रही है. Friends, the today's session will be conducted by my colleague Jayant Dev, who is our expert on the partial discharge. He will be covering the various products that we have for the partial discharge, the various models, the various measurement principles based on which these models are designed. In the beginning, he will be also touching on the theoretical aspect of the partial discharge. What is PD? What are the different type of PDs, etc. So that you are more prepared, when you go to the product side. We will be also conducting a couple of small polls during this particular session. It is just to get some feedback from you. Like, for example, we are conducting these sessions on Saturday, 3 o'clock. So we want to understand from you whether this is the best time for you, whether we continue conducting our webinar series at this time, like Saturday, or we should shift it to say Friday or a Monday, whether the time of 3 o'clock is right, or maybe 4 o'clock or 11 o'clock in the morning will be more appropriate time for all of you to join. So these are certain feedbacks that we look forward to you. Maybe we'll be also asking you some questions related to the products at the end of the session, which product you find more usable to you. So please do participate into that so that we get your feedback and we continue to improve this program. As far as the partial discharge measurement is concerned, as Jayant will explain you, this is a very important measurement, and this distinguishes itself from some of the other measurements, like, for example, we do the thermal imaging of equipment, or we carry out the tan delta measurement, or we carry out some of the other measurements. But the important difference between those measurements and the PD measurement is those measurements will be able to detect the fault when it is beyond certain threshold. The damage is already done. Whereas when we talk about the partial discharge, we are looking at identifying the problem and the cause of the problem at the incipient stage. So at the earlier stage, we are able to identify the issue with the equipment so that we can take the corrective action. So this gives a distinction to this particular measurement, that it really helps in condition monitoring, in kind of a preventive maintenance, and ensuring that we avoid the failures. Because once the damage is done, the damage control becomes very expensive. But if you are able to understand the trend of the insulation failure well in time, we can take the corrective steps to ensure that we are addressing to the problem and we are able to save or enhance the life of the asset. So with this, I once again welcome all of you for this particular webinar, and I hand over the proceedings to Jayant. Jayant, over to you. Thank you very much.
Thank you very much, sir. Good evening, everybody. Once again, from on the behalf of Scope TNM, I would like to welcome you guys to this webinar. Now, let's begin. So this is me. I'll be conducting today's session, and which will be about partial discharge basics as well as about the solutions that is offered by us, Scope TNM Private Limited. This will be our agenda for today. First, we will see what partial discharge is, what are the byproducts that we measure when we measure partial discharges. Then PD testing, how it is done, what are the PD test methods, then what are the various sensors that are there. Then comes our product segment, and then we'll see a couple of case study, and then we can have our question and answer session. So let's begin. So partial discharge. Now, as per IEC 60270, I'm just rephrasing what they have said in IEC 60270 about partial discharges. It is that partial discharges are the localized electrical discharges that only partially bridges the insulation between the conductors and which can or cannot occur adjacent to a conductor, which basically means is that in a particular insulation, in a small portion of that insulation, discharges start happening at a very early stage, which can indicate, insulation degradation. So these are partial discharges that are there that happen in a small portion of insulation. They don't necessarily mean that your insulation has completely broken down. It has not yet lost all of its insulating properties. It's just that it has started deteriorating. And that is what is our major concern when it comes to detecting partial discharges, or when it comes to know about the condition of the insulation of our system. Now, it always happens under high voltage stress. High voltage stress is going to be the prime factor, and that's why partial discharge is a voltage dependent phenomena too. So this is what this statement basically means. Now, what are the various types of partial discharges? When it comes to defining partial discharges in terms, there are actually some broad classifications, but here I have mentioned some common phenomena in terms of partial discharges that we very often get to see in substations. So first one is voids. Now, voids are the air gaps or air globules that are trapped in the solid insulations, like your cable or your bushings, so or your paper insulations. Now, they are highly destructive. By that, what it means is, once air trap is there, I mean, it is a manufacturing defect, of course. It can't happen while the thing is at site. It always occurs at the manufacturing site or at the manufacturing level. Now, once it is there, it cannot be eliminated. It is always going to be there. It's just that over the time, when the insulation goes old, when it grows old, it starts getting even bigger. The void starts, penetrating more inside that particular cavity. That cavity starts growing large. Now, in that way, it becomes highly destructive, because once it is there, it cannot be eliminated, and over the time, it is going to be highly detrimental. It can be highly detrimental. That's why it is recommended, if void is there, you do address to it, or at least you keep a close watch at it. Second type is your floating potential. So floating potential is, in high voltage, as we know, there can only be two potentials. Either it can be high voltage or it can be ground. Now, if there is anything else in between that, it always causes fault, or it always causes something nuisance in our system. Now, by this statement, what I mean to indicate is, like if you have some improper contact, that contact was supposed to either have grounded that particular object, or either would have connected it to the high voltage. Now, if there is an improper contact, due to which there is some potential difference created between the joint and the main contact. Now, due to this improper contact, this third voltage is there. This third voltage comes into picture, which gives rise to floating potential or floating voltage kind of a phenomena. They are commonly found at the improper contacts, like in joints and connectors, and it generally leads to high voltage, high temperature rise at these spots, and sometimes even connectors get melted due to this particular phenomena. Third one is particle discharge. Now, particle discharge is also called bouncing particle. Now, they are the suspending small metallic particles that are there in your fluid insulations, like your SF6 and your transformer oils. Now, once they are there in your insulation, due to one reason or another, contamination can always get inside your insulation level, because we do all sort of maintenance and whatnot. So once they are there, under the high voltage electric field or high electric field that is there, they start moving inside your insulation. On their own, they will not do anything harmful to you, because on their own, they are just some metallic particles who are moving. But under the influence of this high voltage stress, they actually form kind of a charge cloud of charges around them. And when they move. They move with a very high momentum because electric field, your electric field has it travels at the speed of light, right? 3 into 10 to the power 8 meter per second. Now, when they move at this particular velocity, they actually they actually earn quite a momentum. And when they strike against insulation, they actually penetrate those insulation, or at least they leave some dent on it. So, of course, it always happens at nano level or micro level. You won't be able to even look at it with your naked eyes, but that particular thing, it can instigate some future deterioration of your insulation, right? So that's why they are also called bouncing particle or particle discharges, and they are quite detrimental in that way. The only solution, if they are ever detected, is filtration. You can filter them out, basically with the kind of filter paper that you use. You can always do that. Then comes your surface discharges. Now, as the name suggests, these are the discharges that happen on the surface of the insulation. They are mostly found in the your insulation panel. They are your switchgear panels. They are also called tracking or treeing because of the kind of mark that they leave on your insulators, which generally resembles to the root of a tree. That's why they like branching out. That's why they are also called treeing. So this is your surface discharge, which happens on the surface of the insulation. Now, last one is corona. Corona is quite a common phenomenon that we are very well aware of. There are actually two schools of thought. Some people consider them as a full-fledged phenomena, and others consider them as type of partial discharges. Now, when they are considered as full-fledged phenomena, that study is totally different. So their approach of studying this phenomena is totally different. However, when we put them in the category of partial discharges, they are quite a common phenomena that are easily seen in the substations, be it distribution, transmission, or other areas. Now, corona, as we are very well aware, they are actually discharged from the conductor to the air because of roughness of the conductor or bending of the conductor or improper finishing of the conductor. There is always some ionization of air surrounding that particular medium, and due to this ionization, there is the discharge from the surface of the material or the surface of the conductor to air start happening, and we also get to see that in the night quite clearly with a hissing sound. This is corona in terms of severity is considered least because more often than not we get to see that corona is always there, and most of the time we ignore it unless it actually looks like that something bad is going to happen or it has actually turned into something very serious. Now, this is actually most common phenomena and least severe. So this is a brief idea of the type of partial discharges that there are. Now, these are some pictures that can give you a idea of how this partial discharges actually kind of do damages to your systems. There are various pictures of metal clad switch gears where you can see the tracking or surface discharge that has happened and left its mark on them. Then you have got a bushing that has surface discharge on it, but that surface discharge was actually instigated by corona. When that corona was ignored for a long period of time, it turned into surface discharge and it destroyed the whole insulation physically. As you can see, this particular bushing has broken at several places. Then you have got treeing and branching again at the conductor. So this is a picture or a brief idea of how the partial discharges look like or how they damage the insulation. Now, what we measure when we measure partial discharges. First of all, let me take this opportunity to clear one doubt that most of the people have when they deal with partial discharges, that whether the unit you are going to use, is it going to be in picocoulomb or is it going to be in dB? So let me just make it clear to you that when you talk about measuring partial discharges in picocoulomb, you are actually measuring partial discharges electrically. Let me repeat this particular point, that when you are measuring partial discharges in picocoulomb, you are actually measuring them in electrically. By electrically, I mean you are going to make galvanized contact. You always have capacitive coupler kind of sensors. We'll see them later, what these capacitive couplers are and how they appear to be. However, when you are talking about measuring partial discharges, when you are talking about measuring partial discharges in picocoulomb, you have to make a galvanic contact of this coupling capacitor across your insulation. Then you have to make a setup as it is being suggested by IEC 60270. Okay. when you do the measurement strictly as per IC 60270, you get the values in picocoulomb because you are actually measuring the partial discharges. However, in that particular, we'll go in detail of how that thing is and where it is applied. However, when we are doing online partial discharge measurement, so there you don't need to require you are not required to take the shutdown, and you can measure the partial discharges or do the diagnostics in online conditions while your system is live. Now, partial discharges, when we are doing in online condition or running condition of our system, we are not measuring partial discharges per se. I mean directly partial. We are not measuring partial discharges electrically. We are measuring the byproducts of partial discharges, right? So the byproducts that are there whenever there is occurrence of partial discharges are, first of all, is light. Whenever there will be some discharge, there will always be light. It can be visible, it cannot be visible. If it is on the surface, like in terms of corona, you can see it. But if it is happening inside the insulation body or inside your equipment, you cannot see it. So that's one challenge: where to place the sensor, how to place it without breaching the proper construction or the standard construction of that particular equipment, high voltage equipment of ours. So that is one challenge. So light is not quite a feasible solution at this moment. Then comes your heat. So for heat, you have got, whenever there is partial discharges, there is a chance, or it more often than not happens that you get to see the hotspot, but it might not be the case all the time, because partial discharges, as we know, that they are the phenomena that happen in a small portion of the insulation. So if any energy is dissipated in a small portion of insulation, it can easily get dissipated because the volume of your insulation is very large. So you won't actually be able to pinpoint where exactly, or you will never get to know exactly where that particular hotspot was or where exactly that partial discharge was. So again, heat is not that kind of a reliable solution or a reliable way of detecting partial discharges. However, if we are going with heat, we already have IR cameras. So that particular technique or technology is already covered. Next come our chemical changes, or chemical changes that happen whenever there is partial discharge. So for that, we already have gas analysis method, like in transformer oils, we use DGAs, online DGAs or portable DGAs. We already have that technique. Then in terms of SF6, we already have, SF6 gas analyzers. So that particular thing is also covered. Now comes these two topics that are there in the bottom. These are going to be our prime focus for today's discussion. First one is acoustic, second one is electromagnetic. These are basically called on a whole are the wave transmission techniques. Now what happens is, please try to imagine this. You have got a still pond, okay, standing water is there. Now you threw a pebble in it, you just throw a stone in it. So what happens, you can see that there are some ripple of waves start coming out of that particular point where that stone penetrated inside the water. Now considering the same condition, that whenever there is a partial discharge, or whenever there is a discharge, basically there is a dissipation of high energy in a small time, right? You always have that equation of di by dt, but it's just that it is very high in number, because your this discharge is of high magnitude and your time is quite less. So due to this dissipation of energy, these waves inside your insulation, they take place, or even in the air, they take place. Now our target is to detect these waves. They are broadly classified in two terms of acoustic as well as electromagnetic. We'll see them later in detail what they are. So these acoustic waves, they can be in audible range, or they can be ultrasound. That is, they can be about 20 kilohertz also. Then comes your electromagnetic one. So electromagnetic waves are classified into three types: high frequency electromagnetic waves, very high frequency electromagnetic waves, and ultra high frequency electromagnetic waves. So they are just a demarcation of different frequencies that will be covered under these domains, and which are going to be our prime focus today: acoustic as well as electromagnetic. Now, before going any further, let's try to see, as Beer sir was saying, that already we have so many testings, then why we are going for partial discharge testing, which is also one of the questions that people ask more often than not. So in partial discharges, first of all, the information that you get is what exactly is the defect. as we saw earlier, there are various types of partial discharges that are happening, and I also tried to explain to you that which kind of partial discharge is happening because of which kind of physical defect. So you will always get to have a better idea that okay, if this kind of partial discharge is there, so this kind of physical defect or physical nuisance is happening over there. Something bad, like so. For example, say you have the let's say you have the potential discharge, right? So what is that? Why is that happening? So I told you a broad classification of it as if there is a potential discharge, you have got your free potential, the floating potential. You can always indicate that okay, it can be the major reason can be my loose connection. So you can always know okay, it can be due to my loose connection of near the connectors or near the joints. So this is one way of knowing things. You can always identify the cause of that particular partial discharge or cause of that particular discharge in that section of the insulation. Then one of the added advantages, you can always locate these discharges. Now, unlike the methods that are there, like in 10 delta or in IR or in any other method that there is, to the best of my knowledge, first of all, you'll always have to take the shutdown, right? You'll always have to take your system out of the running system. Then you have to do this testing, and it always gives you a broad idea of the condition of your insulation. What is the overall idea? Yeah, insulation is good, insulation is bad. After that, you'll have to bring in your big guns. If you say if you have a CFL, then you can easily pinpoint it. But apart from that, there is only one solution to just replace that particular piece of the insulation. Apart from that, you cannot do anything. However, when you use this partial discharge technique, you can always pinpoint the defect. Always know where exactly is it there inside the insulation. Now, partial discharge is also used as a predictive analysis tool. So using our AI or our diagnostic methods that are there, that comes with certain products of ours, you can always predict that when this particular insulation is going to fail. This is also one thing which is again very highly sought after kind of a technology that is there, which can also be taken care of in terms of partial discharges. Now, as I told this earlier, partial discharge testing is online testing. You can do this testing online very, very reliably. That means you do not require to take any shutdown. So much of a downtime is saved, so much of a cost is saved. So this is why, in spite of having all the conventional forms of testing, all various types of testing, we still go for partial discharge testing. Now, when we test partial discharges, what exactly do we test? That is something that we need to understand. Like earlier I told you, if you are going for conventional kind of partial discharges, you will be measuring PC. However, here you won't be measuring PC, right? So what are we measuring if you are not measuring PC or picocoulomb? So first of all, irrespective of your unit, there are 3-4 parameters that you have to measure in terms of online partial discharges. First one is, what is the magnitude of discharge pulses? What are the magnitude? What is the number that is denoting the severity or the value of partial discharge that is there in that particular portion of the insulation? Then pulse repetition rate, that means the number of discharge pulses per second. That is the rate of generation of pulses, how severe it is, how many number of pulses I am getting per second, which is called pulse repetition rate. Then comes your discharge power. So discharge power is when you are doing with the wireless kind of, this is basically these, be it acoustic method or be it UHF method, they are basically all the sensors that are incorporated to fulfill these particular requirements. They are basically antennas. So they are always capturing these signals. Now, these signals always have a discharge power. They always denote some power or the signal strength that is coming to them. So that also we need to know. On the basis of discharge power, you can always know, or you can always demarcate how much is the partial discharge, how much of that particular power has partial discharge and how much of that particular is noise. So that is one thing that we need to know to predict how severe that particular discharge is. And the last one is to know the type of partial discharge, so that you can always decide what kind of a predictive action or what kind of corrective action you must take. So this is our why and what in terms of partial discharge testing. Then comes our testing. Now, what is the correlation with the other tests? With reference to the tests that are there, you can always find a correlation. So in terms of DGA, you have got 60599 IEC, and it has one database of DC10 where they have defined what kind of ppm of let's say hydrogen or acetylene denotes a partial discharges. Apart from that, you have got your dual triangle, or you have got your different gas ratios. They always denote what kind of a number or what kind of a figure denotes to partial discharge. In dual triangle, as all of you guys are aware, at the very peak of it, of that particular triangle, you have got partial discharges there. So that is one correlation for you. Then comes your 10 delta. 10 delta is not directly correlated with the partial discharges per se. However, whenever you have done 10 delta, let's say, and you have already measured it, and you can say, yeah, 10 delta is not good, you can always do partial discharges there. There are chances that you will always be able to detect it, because 10 delta has denoted that the insulation degradation is happening. It is there, but you won't be able to pinpoint it using 10 delta. So you can use partial discharge to detect it. Same you can do with your IR testing. Then comes your thermography. Now with thermography, there is one thing, please let me clear this to you guys, that this is one question that people ask more often than not. If I am already doing thermography, then why do I require partial discharges? So please let me tell you that partial discharges, as I told you during the definition also, that partial discharges are the indication of inception of the insulation degradation. That is at the very basic level, at the inception level of the insulation degradation, you can detect partial discharges. However, you won't be able to detect that with the help of thermography, because it is so small in its shape, it's so small in its size. I mean, by it, I mean partial discharge, that the heat that is generated at that particular point due to partial discharge easily gets dissipated throughout your insulation, right? So hotspot will not occur. To have a hotspot, you always need that the heat generation should be greater than your heat dissipation at that particular point. However, in terms of partial discharges, at its very beginning, you will always have heat generation lesser than the heat dissipation, which means the energy will easily get dissipated throughout the insulation. So you will never get that particular hotspot at the beginning level unless it has really gotten deteriorated so much that you can easily see that, yeah, hotspot has started occurring on, and it has, that particular discharge has come to such a bad level that now that particular thing can be seen as red hot. So this is one demarcation between thermography and partial discharges, that thermography can only detect it once it has become quite bad. However, in terms of partial discharges, you can detect it at the very early level. So this was the correlation in terms of the conventional methods, or the very well-known methods. Then comes the steps. Now, this is the analytical technique that is generally adopted, or that is generally followed when we detect the partial discharges, or when we do the analysis of partial discharge. Or there is one more, let me rephrase this, when we do the PD diagnostics. So the first one is detection. You should always be able to detect it. So to detect the particular partial discharge, like we saw, acoustic and electromagnetic, you need to have that kind of sensors. You have to decide what kind of sensors you are going to use. That we'll see how to do it and how we do it. Then you should always be able to identify the kind of PD. You have detected it, that is fine. Partial discharge is there. Okay, good. Now what? The second thing is, you should always be able to identify what kind of partial discharge is there. As we saw, depending upon the different partial discharge types, every kind of partial discharge, it denotes to a particular physical defect. So once you have identified the PD, you can always know what kind of physical defect is happening. So first step is detection. Then comes your identification. Third one is, okay, PD is there, this kind of PD is there. That is fine. Now, where exactly is it lying inside my whole insulation? Okay, if it is happening, let's say in a transformer, I was able to detect that partial discharge is there, and this kind of partial discharge is there. Okay, fine. Now, where exactly inside that transformer? Transformer has a huge dimension depending upon its kVA level or MVA level. So there, this localization facility can really reduce the downtime if you ever take a shutdown after doing on the basis of partial discharge report, that, yeah, I need to fix this particular problem in that particular transformer on the basis of partial discharge report that you got. So localization is equally important. And last but not the least, in fact, it is quite important that you always do the trending of your analysis or trending of your data. That, okay, on a certain date, I did partial discharge measurement or I did PD testing, I got a certain value, but that one value cannot decide everything, cannot decide your future course of action. You should always do the trending. That means next time, whenever you're doing the partial discharge testing, let's say you decided a frequency of 6 months or 1 year, whatever it is. So next time, whenever you are doing the PD testing, you should always record that data also. And you should put it in such a way that you should be able to correlate these two values, right? Only then you will be able to see the rate of change, just like what we do in the case of DGS, especially in online DGS. We always go for the ROCs, as has also been suggested in the IEC 60599, that not just ppm, not just gas ratio, you should always see the ROC, that is the rate of change of the gases. So similarly, in partial discharges, you should always also do the trending of the data. You should also try to see the rate of change, that how much is it changing, right? So that is equally important. So you've got 4 steps in terms of partial discharge diagnostics. First one is detection, identification, localization, and trending of the data. So hope you are following with me till now. Next comes the PD test method. So it is quite important for you to understand, or for any of us to understand, what exactly is it that we are dealing with, and how exactly are we dealing. So in partial discharge test methods, there are actually 2 methods. First one is your offline method. Second one is your online method. So by offline, I meant like the one that I was talking about earlier, your PC method, or the method with which you are measuring your partial discharges in picocoulomb. So these are the methods that are employed in controlled environment, where you have totally neglected all the noise, surrounding noise and everything. You have no interference, nothing. There is no noise coming to you, because in manufacturing level or in lab facility, you always have a Faraday cage. You can always have fluctuate your voltage level, as most of you guys are aware of, or all of you guys are aware of. You always need to measure PDIV and PDEV, right? You need to know when the partial discharge got instigated and when it got extincted. So those numbers and those analysis tools are used, and they are used in the manufacturing facilities or in the lab facilities. So for that, you have to take the system offline. You are taking that particular unit of the system out of your line, and then you can do it. So this is one thing. However, when we are in the site and we are doing the PD analysis, we cannot have that kind of a control environment. We cannot have a variable voltage source, and so we have to adapt. Now, when we adapt, we have got actually 2 methods. So first way of measuring partial discharges in online method is portable one. In portable one, we have got condition-based monitoring equipment, or condition-based testing equipment, where we carry portable equipment to the site. We do the PD testing and we come back, and we load that particular data in our database, and we start doing the analysis. That is one thing. So whenever the condition requires, we do the testing and we come back. That is a portable one. Second one is a continuous monitoring system, which is like any other system. You have your sensors placed, and you have drawn cables, and using various architectures, you have gotten that particular data in your PC, and you can see it there. So that is your continuous monitoring system, where you are seeing that particular data in 24/7 manner. And in portable one, you are carrying your kits. This is the basic idea. In the online condition, you do not require to take the shutdown. In offline condition, you do require to take the shutdown. Apart from that, there is one more demarcation, that in offline condition, IEC 60270 and other IEC standards, which are also dedicated for certain equipments like generator, transformers, they have defined some safe value of PC. That if PC level is below this number, it is safe. Like in case of GIS, if it is less than 5 PC, it is considered safe. By PC, I mean picocoulomb, right? However, in terms of online partial discharges, there is no definite value suggested by any IEC, IEEE, SIGRE, or any other standard. So please keep this in mind, that when you are going for online solutions, you have to rely on the methods that we discussed earlier, or the analytical technique that we discussed earlier, that you have to do the detection, identification, localization, and trending. So on that basis, you can easily correlate with the data. However, there is no safe value defined by any of the international standards. Now, these are the 2 techniques that are there, available there. Wave emission technique, that is, first one is acoustic and second one is the electromagnetic one. So in acoustic one, you have got two kind of sensors, airborne probe and the contact probe. Airborne probe is the one that you keep in your hand and you just point it in a certain direction without coming in contact with the insulation and do the PD testing. And the contact probe is the sensor that is placed on the grounded metallic body to do the PD analysis. Then in electromagnetic one, you have got three kind of frequency ranges and three kind of solutions. So you have got high frequency, very high frequency, and ultra high frequency. In high frequency in high frequency band, you have got two kind of solutions that are there: HFCT, or which is also called RFCT, which stands for high frequency current transformer or radio frequency current transformer. Then second one is your coupling capacitor. Now these sensors that I am discussing over here, they can look different for different manufacturers. They can bear a different name under different manufacturers. However, the solutions that I have discussed over here are everything that are technically, economically available in the market. So these are generic names that more often that are used in the standards also, or in different recommended papers also. So you can use these names as it is, without having to stick to a particular make or a particular manufacturer. Then comes your VHF, that is very high frequency. So your transient earth voltage, these particular sensors, they actually come in the category of very high frequency. And last one is ultra high frequency. So in ultra high frequency, you basically have got three kind of antennas. First one is your internal antennas. These are also called internal sensors, internal UHF sensors, which are quite popular in terms of GISs nowadays. So internally mounted sensors are delivered at the customer's premises to do the PD analysis of GISs. Then comes your external sensors. These are external UHF sensors that are again placed on the surface of the DUTs or surface of the HV equipments like transformer or GISs. Then comes your UHF antenna. So these are the antennas that are handheld kind of antennas, which are taken outside and pointed in the direction of a particular equipment or insulation to get a to do the partial discharge measurement. So this is a basic gist of what are acoustic sensors and what are electromagnetic sensors. Now let's see how they look like. So this grayish one, that is top left, these are various UHF sensors. The left two one are the antennas. These are the handheld antennas, as you can see, which are pointed in the direction of the insulation to do the PD monitoring or PD testing. The third from the left is your external UHF sensors, which is generally mounted on the insulation barrier of your GISs. And the fourth from the left is your internal UHF sensor, which is already placed inside the GIS. So this is the top left. Top left is your UHF sensors. Then comes your right one, which has with the green background. These are your acoustic sensors. The top one is actually contact kind of acoustic sensor, and bottom one is your the antenna, the contact-less kind of a sensor, or parabolic dish kind of a sensor, which it is also called. And the sensor right in the middle, the three sensors that you are seeing with a white background, they are the TEV sensors, right? Then comes the sensors which are in the bottom left of this particular PPT with a pinkish kind of a background. These are your coupling capacitors. So here, if you can see, let me just turn this on. So here, just a moment. So this is HFCT, this is HFCT, this is HFCT. Here also it is all are HFCTs of different types and different dimensions as per the requirement of the customer. And this one that you are seeing, this is your coupling capacitor. So it is actually a miniaturized bushing that is used to measure the partial discharges. Generally, it is used in generator monitoring, as well as it is also used in offline PD testing as per IC 60270. So this is extensive PD solutions that are available with us, or different sensors that are available with us. I just wanted to show physical sensors to you, so you can much more relate with the things that we mentioned earlier. Now comes the solutions that we have to offer. So first one is our very basic solution, which is handheld kind of a PD detector, this which is called 3i. Now, this particular sensor is quite handheld one. It is just like your TV remote, and it has operability of with the two buttons, quite a simple product to handle. As you can see, uh, it has got actually external sensors also with it, like external UHF sensors are external acoustic sensors are provided with it. Apart from that, there is one RFCT and the TV sensors are also provided with it. Apart from that, it has got inbuilt acoustic as well as TV sensors. Now, this handheld particular kit is quite useful in detecting partial discharges when you just want to, have an idea of whether partial discharge is there or not. It is a basic detector. It does not possess the kind of analytical technique that we have discussed earlier. So when you are starting out to do partial discharges, most of the times, this is the kind of solution people go with. This is one of the most important equipment or devices that can be used with your switchgear panels. It is quite focused on that, and apart from that, you can also do the testing of various equipment like transformers or your cables, cable joints in your GI in your substation environment. So this is one of the basic equipment 3i that is there. Then comes your NL camera. Now this is one product which we are promoting right now on behalf of NL Acoustics or NL team, NL company. It is not manufactured by DIMRUS as was mentioned by BR sir. This is actually being manufactured by NL, that is noiseless company, which is a Finnish company, which has recently launched its product in India during the Electrama, and we are the exclusive channel partner of its in India. Now, what this particular product is, let me tell you. It has got 124 number of microphones embedded on its front face that you won't be able to see over here. It has a facility of visualization of the partial discharges or the source of the sound that is there due to the partial discharges. Let me show you here what I mean to say. So here you can see this particular phase, or this is
Jayant, we are not able to hear you. Jayant?
pardon me, there was a bit of a glitch with my system. Coming back to the subject, so here, as you can see, here, this particular system has pinpointed the source of the sound, right? And apart from that, it has used your PRPD, a very well-known phenomena or analytical tool. PRPD is, let me take this opportunity to also discuss this particular technique with you, that PRPD is one of the technique. PRPD actually stands for the phase resolved partial discharges. That means with the reference to the phase of your system, that is your if you draw your system as a 50 hertz supply that we get, and if you draw a sinusoid on the basis of that, or on the basis of the phase of your system in between 0 to 360 degree, where exactly those discharges are lying, right? This is a one analytical tool that is suggested by IEC 60270 to do the PD analysis, and on the basis of this particular tool itself, you can define various types of partial discharges. So depending upon the various waveforms, you can define the various types of partial discharges that are there. Now, as you can see over here, you can have the PRPD as well as you can visually see the location of the partial discharge. This is quite a useful tool when it comes to visualizing where exactly is it, by keeping yourself at a safe distance, as you can stand to a distance as far as 100 meters and still be able to detect the partial discharge noises, because you are using 124 number of microphones or 124 number of acoustic and ultrasound sensors. So you can easily do the PD detection using this particular kit. This is quite handy when it comes to your substation surveying, or when it comes to your PD detection and localization in terms of your transmission lines specifically. This is quite a good solution. We here in India, we have started doing demonstration of this particular kit. We have a demo unit with us, and the kind of response that we are getting from the customers is quite overwhelming, depending on the basis of the performance of this kit, as it has been quite helpful in telling them where exactly the partial discharge is there in their system. So this is one thing. This is one solution with you where you can visually see the location of partial discharges. So this is quite a product of its own segment. So after this, you have got your DIMLOG 4. So DIMLOG 4 is our handheld surveyor tool. So it is actually all-rounder kind of a product that we have, as it has acoustic as well as electromagnetic sensors of all kind. In 3i, we had only acoustic as well as TEV. However, here you have got acoustic, TEV, RFCT, UHF, all kind of sensors adaptable used with this particular kit. It is quite a surveying tool, and it is quite actually a higher version of what we are providing with the 3i. So it has got all the extensive or advanced analytical tool with it. So you can easily locate, detect, and identify various kind of partial discharges that are there in your high voltage equipments. Next comes your AR700. Now this is one specialized tool to localize partial discharges inside your transformer bodies. Now it has got, as you can see over here, it has got 4 number of this vertical kind of 4 sensors as you are seeing. They are contact kind of acoustic sensors. Apart from that, it has got quite a analytical tool that is there with it. That is, as you can see over here. Let me use the whiteboard once again. So here, as you are seeing in this particular diagram, this particular system AR700, it uses actually AI engine that is there with that comes freely with this particular product. You can put these sensors, as you can see over here. 4 sensors have been placed on the transformer body. Using the coordinate geometry, you can always get the dimension of your transformers, right, while doing the testing. So when you place these sensors like a square, or somewhat like a square or a rectangle also, on the surface of the body, and putting the coordinate inside the software, you can always pinpoint your partial discharges, as you can see over here. Inside the transformer, it could easily pinpoint the partial discharge. So this is one specialized kit for detection of partial discharges in transformers, rather not detection, localization of partial discharges in the transformers. And you can always do the trending of the data also, which is, by default kind of a feature with all our equipments, because the software that we provide with all these solutions, they are the common one. All you have to do is to, whenever you connect these products with the particular software, you have to check that, yeah, I'm going to do the testing with this particular product only. All the product come on the same software. So once you have adapted yourself with one product, you can use the software very easily. Apart from that, we have got one more specialized kit. This specialized kit is for cables. This can be used for cables, transformers, and GISs. Let me tell you what it is. Now here, it has got actually 2 models. This one is 3-channel. This one is 6-channel. So by channel, I mean you can insert 6 number of inputs, as it is a 6-channel equipment, and it is a 3-channel equipment. So you can take input of 3 numbers in this. They don't vary too much. It's just that they vary in the terms of number of channels that they have. Now they have changeable, interchangeable, or switchable 2 frequency band. That is high frequency as well as ultra high frequency band. So in high frequency band, you can do the PD testing of cables. As you can see over here, RFCTs are there. RFCTs are actually the products that are recommended to do the PD testing of the cables. So with RFCT box, or this particular if you are doing with cable only, you will order only this particular product and you can do the PD testing of the cable. When it comes to PD testing of your generators, you will order coupling capacitors. As while discussion, I told you that coupling capacitors are used for the monitoring of generators. So these are your coupling capacitors, as you can see over here. These are the miniaturized bushings. Then when it comes to GIS, as we are aware that GIS, in terms of GISs, it has been suggested that we take the UHF frequency band. So these are your UHF sensors, external UHF sensors. Internal UHF sensors can also be provided with this particular solution to do the PD testing of GISs. So this particular product comes in these three segments, these three target areas: cable, generators, and GISs. With this particular product, you can actually localize, that is, you can actually pinpoint the defect that is there in the generator, in cable, and GISs. The earlier product that we saw, AR700, it is a specialized product for transformers, which works on the principle of acoustic band. So these are our portable product in general. And we also have continuous monitoring solutions that are there with us, but it is not in today's, it is not covered in today's lecture or in today's discussion. However, if you guys are interested, we can cover them in some other session. So let me just give you a brief idea of the product offering that is provided by the scope by giving, let me explain this particular table to you. So in terms of detector, or if you, this is a broad classification of the solution that people generally ask for. First is detector, then is surveyor, then is analyzer, and 24/7 monitoring solution. In detector, people are actually concerned more about detecting partial discharges and trending the data. These particular products are called detectors. Then are the surveyors. Surveyors are your basic surveying tools that you take out in the field and you do the PD testing. Then you again do the trending of that particular data. However, analyzer are the specialized kits to localize the partial discharges, where exactly inside the insulation or inside my equipment the partial discharge is happening. So this is these are the analyzers that I had discussed with you. Then comes your 24/7 monitoring solution. So for transformer monitoring for equipment monitoring solutions, we again have complete range of products, as you can see over here. So the basic focus of this particular, to show this particular table, was to tell you or to exhibit to you that we have got complete range of solutions to your different. Now, let's come to discussion on this hormone. Now, this is one GIS monitoring solution that we provide. This is for continuous monitoring solution. It has got 100. It supports actually 600 number of sensors in one network, which is good enough to monitor any GIS substation at a time. Then this is specifically for GIS. Then comes, this is the software configuration that is provided by it. It can be incorporated with your SCADA, and various values of partial discharges in real time can be seen in this particular software. Then comes your PD analyzer for transformer. It actually has got supportability or adaptability to 80 number of sensors: temperature, humidity, all kinds of sensors can be taken in this particular module. In fact, if you have got online DHA mounted on your system, that input can also be relayed to your SCADA system or to your monitoring, whatever display unit or monitoring unit that you are using. You can always relay that particular data using this transformer monitoring equipment. Now you can do partial discharge monitoring, bushing monitoring, load current monitoring, everything that you want to do, or which is possible to do the monitoring in a transformer, can be supported by this particular solution. Then this is again one software interfacing, how it looks like, how the values are displayed. Now comes your PD analyzer for cable. So in terms of PD and to do the PD monitoring of the cable inside a particular substation, or most of the time when whenever cable is laid between two substations or 2 points. So it can be used for internal PD monitoring or inside the substation, or also it can be used to do the PD monitoring of a cable that is shared by two substations or two subjects. So this is one solution that is also available with us. Now, these were our continuous monitoring systems for there is one product that I actually missed here, was continuous monitoring solution for generator. It also looks like the same, and can also be dealt in detail if you guys require. So as we saw, we have got continuous monitoring system for GIS, for transformer, for cable, and one that I missed in generators also. So apart from the portable one, we have got extensive solution of the monitoring products. So DIMRUS, as BR sir said earlier, that it is a 25 years old company which exclusively deals in terms of partial discharges, has all kind of solutions to cater to your needs. Now let's see the software features that are available with these products. So this is one common platform for our portable solutions. As I told you, in the right side, as you can see, various products are shown here, and whichever product you are going to use, all you have to do is to check those particular products, and rest you can leave unchecked to do the testing. And this particular software is capable of doing the partial discharge testing or analysis in all our product ranges. So it's not like you have bought one product. So for that you have taken one software, and for other product you need to take other software. With one software you can do all the solutions. You can cover all the products. Now in our software, we have got the facility to do the automatic analysis. As you can see here in the bottom, let me highlight this for you. Automatically, it has told you these datas, the kind of partial discharge that is happening, that is the type of partial discharge as I was talking about, then the total power of discharge that is happening, then you have got your magnitude of discharge, then you have got your accuracy. By accuracy, it means is because it is AI powered, right? Artificial intelligence powered engine is there. So it always verifies whether this pattern or whether the partial discharge is actually a partial discharge or not, or how sure my system is whether it is a partial discharge or not. So for that we use accuracy level. So you have got at automatic analysis, then you can always do the filtration of noise as I was talking about. Let me just use whiteboard once again. This is actually what the PRP looks like. Here, as you can see, you have taken one sinusoid, that is, you have taken one reference of your 50 Hertz supply or whatever the running frequency band is, or the running frequency of your system is, and on the basis of that you try to analyze the cluster of these pulses, partial discharge pulses. Where exactly are they lying in the phase from 0 to 360 degree? Where exactly are they lying? So on that basis you actually try to identify the kind of partial discharge that is there, which is suggested by IEC 60270. Now comes whenever it is noise, it will never follow this definite pattern, because if it is a partial discharge, it has to have a cluster of pulses in a definite period of time, right? It has to be repeatable. But in terms of noise is haphazard. Noise can be anything. So it is very easily to demarcate between partial discharge signal and noise. Now, you can easily identify the PD type. As we saw here, it has identified it as internal PD automatically. You don't have to do anything. So that is one added advantage of it. And then apart from that, it also shows you the PD source localization. That is where exactly the partial discharge source is. You can do that with the help of this particular software automatically. Now, apart from that, you have got your automatic report generation as well as your trending of the data. So by trending of the data, as I discussed before, you have to keep a record of your data safely in your equipment. Because in partial discharges, let me focus on this. Let me put pressure on this particular point, that apart from taking the partial discharge measurement, keeping a proper documentation of the readings is equally important. Please keep this in mind. Whichever unit you purchase or whichever partial discharge device that you use or purchase, you always ensure that there is a proper documentation. There is a facility to do the proper documentation in your device or in your software. Now, here also I have here also, as you can see at the top, it has in the automatic analysis, it has identified a particular pulse or a particular signal as noise. As you can see over here, let me use the whiteboard once again. As you can see, as compared to the earlier one, there is no cluster happening anywhere. It is just, continuous sound like a thing is coming over here, and it will easily demarcated it as it is noise. It is not a partial discharge. However, whenever it is a partial discharge, as you can see over here in the PRPD, there is a certain kind of shape that forms. On the basis of that, it tells you whether it is a surface discharge or internal discharge, as it is one kind of a surface discharge that is being shown over here. Now, the various analytical tool that comes with this particular product is, first one is automatic noise rejection, as I shown you here. Also, I discussed earlier in the earlier slide. Then comes your PRPD, phase resolved partial discharge, which is suggested by IEC 60270. Then comes your three-dimensioning. So in three-dimensioning, you basically, in PRPD, as you can see over here, you are doing the two-dimensional measurement. That is on the basis of the phase, that is 0 to 360-degree phase of your system voltage. What is the magnitude of partial discharges, or where exactly are they lying in the phase? However, in three dimension, you can see those waveforms in X, Y, and Z coordinate, and you can just visualize it better, whether it is a partial discharge or it is a noise. Then comes your PD cloud. PD cloud is here. Let me use the whiteboard once again. This is your PD cloud, which is used when you have, it is actually quite an extensive unit when you have quite gotten grasp of the particular PD kit or PD analysis. You use this particular technique to know if there is more than two source of partial discharge that you are getting, to demarcate between different kind of partial discharges if they are there. So these are the facilities that comes with our software. Then the PD source localization, which is very important, which works on the principle of time of flight or time of travel to do the pinpointing of the partial discharges. So these are the complete solution features or the software features that you will get with our software. Now let's have a look at a couple of case studies that we have to show you what it looks like or what our products are. So in this particular slide, as you can see, this was actually done in a 400 kV GIS. It was an interconnecting cable from a transformer to GIS, where the customer was suspecting PD. We used our RFCT sensor as well as our handheld PD analyzer kit. Here we tried to pinpoint the partial discharge, and if you can see over here, the cable length was 90 meters, and our sensor, it pinpointed it at 15 meters from the transformer. Actually, they had recently, they didn't tell us this thing, but after we pinpointed it, and the point there where it was located, that 15 meters from the transformer, there it was a dug-in that they had already formed. So later when we pinpointed it, they told us that a couple of days back, before this testing, they had actually maintained one joint. They had actually done work on that particular joint. They had changed it, and they just wanted to make sure that everything was fine. And still there was some partial discharge happening over there. We submitted our report to them and told them to keep a close look at it, because it was a floating potential kind of partial discharge, as we saw earlier, which is there due to loose contact in joints as well as connectors. So this is one product. Then comes our this particular product was used in a 220 kV GIS in a factory setting. So here actually customer had put some nuts, okay, some nuts inside the GIS as it was in a factory, so it was all done in a controlled environment. They had put these nuts inside the GIS without telling us, and they told us to pinpoint this particular nuts. And also, without telling us that they have put nuts, they told us that we have created some defect. It is your job to pinpoint it, or at least tell us whether it is there or not. So we went over there, we do the PD testing, and we identified that it was floating potential kind of partial discharge, as well as we located the partial discharge to the accuracy. Accurately, we located the partial discharge, that yeah, here there is some nut or something is lying over there, and they knew it, and they took out they took that GIS out of the supply and they checked it, and it was there. So this is how the system looks like. This is how the solution is provided, and this is how the solution is seen in the practical. So you get to see the type of partial discharge, whether partial discharge is there or not. Then we can do the PD localization, and we also do the trending of the data. So this is the end of my presentation, and I would request you guys to ask questions, as many as you want. Hello, BR sir.
Yeah, Jayant, I'm here. There are a few questions which are asked. You can have a look at that on the chat.
Okay.
But one of the question which was asked is, was related to the values, like, what can be the PD values for the dry type transformer, or for that matter, a GIS, or for that matter, a hydro generator, or that kind of a product.
Right.
Because you can elaborate on that. There was also answer given by Mr. Ashok Kumar that 5 PC is permitted for the GIS.
Yes, sir.
So maybe you can elaborate a little bit about, when we use PC as a measurement unit, and then what are the values, and typically when we are using these kind of methods that we just spoke, how, what is the thing that is measured, whether it is dB or how it is.
Okay, sir. Okay, sir. Got it. Thank you for clearing that out, sir. So let me again put this point to you guys, that even earlier I told you that there is a confusion in terms of using in terms of measuring partial discharge in terms of PC or in other units. And then this second question arises, that if whatever the way you are measuring it, what is the safe value? Now, the answer that was given by one gentleman, that it is less than 5 PC in terms of GISs. So now this particular 5 PC value is again one value that has been recommended actually by IEC as well as SIGRE. Now what they do is, once they have commissioned the GIS, how this basically works is, once they have commissioned the GIS, they do the sensitivity verification. Okay, that means the partial discharge that are there, the sensors that are there, they must have a sensitivity of 5 PC. That means if a partial discharge of less than 5 PC is there, they should be able to detect. That is one part of it. And sensitivity verification of various sensors is done on that basis. There is a SIGRE note on that, which is actually considered a standard to ensure or verify the sensitivity of these sensors. And from there, they have considered that, okay, if it is greater than 5 PC, if partial discharge value is greater than 5 PC, it is a partial discharge. It is a destructive one, and you have to take measure of it. Now, when you go out in the field and you do the partial discharge, even of the GISs, in online condition, you cannot measure partial discharge in terms of PC. As I was telling you earlier, that in online technique, because the technique that you use to do the partial discharge measurement in case of GIS, it is a UHF technique. Now, there is no correlation. Rather, in a couple of IEEE standards and a SIGRE technical brochure, they have clearly mentioned it. There is one application guide of SIGRE where they have specifically mentioned it, that there is no correlation between picocoulomb or one online unit that is used to measure partial discharge in GIS, which is called dBm. That is the discharge power. This is one quite common a unit that is used for online measurement of online PD measurement in terms of GIS. Now there is no specific correlation, so you cannot know in online condition whether the value that you are getting in dBm, what is its equivalent in PC. So for that, there is one limitation when we are doing with the online one. That's why in online one also, in online partial discharges also, what they are doing is they are doing the comparative analysis. That okay, today it is this much dBm, and then it is whether it is changing or not, or is it keeping the safe. So this is one gray area, as I was telling you guys, that no specific value has been defined by any standard as such. All these values that are defined, let's say in terms of PC. Now, when let's say in terms of like when Om Prakash Pokharel sir has asked, what is the recommended PD value for hydro generators and power transformers? So I'll have to look at the specific values. I don't exactly remember in terms of in terms of picocoulomb, but for transformer, if I'm not correct, it is I think less than 100 PCs, sir. I'll have to again check it, and I think the same goes for hydro generators. But when it comes to, these are the values of offline partial discharge measurement. That is, when you have taken the system out, you are charging your particular system with a variable AC source, which is PD free also, and then you are doing the PD measurement using the conventional sensors, right? As per IEC 60270, there various PC values are defined. But if you are going with online values or online partial discharge measurement, you won't get PC per se. So it is quite tough to tell whether, I mean, in terms of numbers, that yeah, if it is this value, so it is partial discharge, or if it is lesser than this value, it is fine, or it is greater than this value, so it is bad. So this is one limitation. Now, I hope I was clear on this. If I'm yet not clear on this, please, you can type the question again in the chat. I'll try to elaborate more on this point. Now, Nitish Bagh sir has asked, NL camera only detects surface tracking. No, sir. It can detect a whole kind of every kind of partial discharge that is there. It will detect your surface tracking. It will detect your floating potential. It will detect your corona. It will detect any kind of partial discharge that is happening. We have a, I mean, if you are really interested in this particular, you can please put that, I mean, requisition in our email. You have got our email, and we can, organize one presentation on that particular product also. This is there is no limitation of identifying the type of partial discharge with this camera, sir. Now, Shibu Chakravarti sir has asked, Shibu Chakravarti, PGCL Siliguri substation. Okay. Electromagnetic, Jatinder Bhamra sir has asked how electromagnetic wave can be detected and what is the unit of measurement? Electromagnetic wave unit. Okay. Sir, the electromagnetic wave are actually being demarcated into the three types, as I told you: high frequency, ultra high frequency, and very high frequency. Now, they are again measured with the sensors. Now, these sensors are basically antenna, as I was telling you earlier. So these antennas, they capture these waves of electromagnetic frequency that are approached to them, and that is how they show the value. Now, in high frequency, if you can remember what I was discussing earlier, you have got actually two kind of sensors in the market. One is high frequency CTs or radio frequency CTs, or you have got your coupling capacitors. So when you are dealing with actually coupling capacitors, there you can get the value in PCs, in picocoulomb. There you can get it because you are galvanically connect your generator terminals to a particular capacitive coupler. So there you can do it. So in terms of, if you are using coupling capacitor, you can get the values in PC. However, when you are using RFCT or HFCT, you can choose to get the values in millivolt or dB, as well as in PC. But that PC is not I mean, this PC is not actually the picocoulomb that we guys use, we use on the basis of standard, because it is capturing again the PD pulses of high frequencies that are trying to escape from the grounding circuits or the grounding part of the bodies. So this is common unit of electromagnetic waves, sir. And then when it comes to TeV sensors, the common unit is, sir, again millivolt. And when it comes to UHF sensors, as I was telling in terms of GIS, UHF sensors generally have a unit of, sir, dBm. dBm, which is also a unit for discharge power. I hope I was able to clear this doubt. Then please highlight generator PD analysis. So in generator PD analysis, sir, what I mean, let me try to give you a brief idea or how it is done is. So what they do is they actually put capacitive couplers, these miniaturized pushing sensors, in connection with your three terminals, RYB, the outcoming terminals of your generators. And on the other part of that particular sensor are the signal cables. So this particular bushing sensor, what it does is, it basically acts as a step down capacitive arrangement. Okay. So what it does is, I mean, whatever is the voltage level of your generator, it actually steps it down. It captures the partial discharge signal or partial discharge current or PD transient that are coming. we take the output from that particular signal terminal of that pushing sensor, and we can put it in we take that particular input in your PD device. It can be PD analyzer, it can be your continuous monitoring system. We take that particular in it, and we connect that particular monitoring or detection device with our PC, and we can easily analyze it using our software. So this is basically how we do the generator PD analysis. So Anil Jasani sir's question has been answered, that yeah, we provide the service for PD testing at various substations for switchyard as well as power transformers. Okay. Pawan Sharma sir, can we use PD to check condition of insulators on 33 kV line? Of course, sir. Actually, partial discharge is recommended to be done, or PD testing is recommended to be done above 3 kV. Above 3 kV, whatever the system is, irrespective of its configuration, you can always do the PD testing. Then Jatinder sir, hope you got the answer, because you asked this twice, that what is the unit measurement of electromagnetic wave. So electromagnetic wave on the whole is not measured, sir. It is broken down in 3 types: HF, VHF, and UHF. And on the basis of that, I already gave the answer. I hope you got it. How electromagnetic wave used for measurement. So for again, Jatinder Bhamra sir has asked electromagnetic wave used for measurement. So these actually various waves are various frequency bands are defined, sir. So on the basis of and various antennas are used that capture only those frequency bands. And as I discussed earlier, that you have got UHF antennas, you have got your HFCTs, you have got your TVs. So these definite antennas or these particular sensors, they capture these waves, right? And they relate to your measuring unit. And from that, you can put it to your monitoring unit, whatever device that you are using. It can be a PC, it can be a laptop, and you can monitor the data using our software. So Sandeep Lashkar sir has asked which equipment can be tested with use of PD measurement. Sir, all the high voltage equipment which operate above 3 kV can be detected using the partial discharge measurement, or partial discharge measurement can be performed upon them. Then what is PC? Okay, so Sandeep sir, PC stands for the picocoulomb. It is one measurement of measuring the charges or the discharges in this particular sense, because there is one term, if you guys will go through the standards, apparent charge. When you measure the partial discharges, you basically measure the apparent charge. Okay, so that's why this is one standardized unit that is used all around the globe of PC. Okay. Pawan Jadhav sir, yes sir.
Yeah, there was one question from Mr. Pawan Sharma. Can we check discharge in indoor 33 kV switchgear panel?
Yes sir.
Yeah, so that you can respond what can be used.
Okay, sir, in that particular product of its to measure the 33 kV switchgear panel, you can use, sir, our 3i solution or our DIMLOC 4 solution. So there you can use your acoustic sensor as well as your TV sensor, and if the if you are interested in the grounding across the plate, across the grounding plate, you can also use our RFCT sensors. So these are all supported by these two products of our 3i as well as our DIMLOC 4 solution, and you can do the PD testing of switchgear panels, sir. Pawan Jadhav sir has asked, sir, elaborate PD patterns and its causes in PR PD measurement. Pawan sir, actually, I don't have that database with me right now. However, I can recommend you to go through the IEC 60270 standard if you have that particular database with you, or you can also refer a couple of SIGRE technical brochures. There they have actually exclusively defined various type of PD patterns and how to identify them. I don't have that with me right now. So please, if you can go through them, that is fine. Otherwise, you let me know. I'll try to we'll try to see what we can do in this term. Send me write-up of this at, okay. How limit dB for 33? Nitish sir, Nitish Bagh sir has asked how limit, I mean, what is the limit in dB for 33 kV metal clad panel. Sir, again, as I told you, there is no IC or IEEE or IS or SIGRI standard which has defined dB level for any kind of partial discharge testing. There is no limit defined as such. However, various manufacturers are providing various values that, yeah, if it is below this, it is partial discharge, or if it is above this, it is partial discharge. However, I follow, or we follow, IC standard or IEEE standard. So they have not defined anything. So it is tough for me to say anything like that. However, let me tell you, whenever you are using, that's why this trending method has been recommended to you guys. So let me explain to you how this works, especially in terms of, let's say, metal clad panel. Suppose you have got 5 panels in a room, okay? And recently I also did the same in one of the substations, and there they cross-checked it with one of the manufacturer. I'm not at the liberty of taking the name of the utility as well as the equipment manufacturer. So they already were using one of the PD kits. Again, handheld kit was there. So they did PD testing in a particular, in their switchgear panel. 5 panels were there. So they did, and this particular kit that they were using, it has a facility to tell you if it is above. It works on the principle that if the value is above a certain dB, it will tell you that, yeah, it is partial discharge. It will simply tell you, yeah, it is partial discharge. If it is below a certain level, it will tell you it is not a partial discharge. So that kit was there with them. However, our kit, I took my 3i kit with me. I also did the PD analysis on that particular panel. So what basically I did was, I took reading of all 5 panels, and I could clearly see that the 4 panel had a okay kind of reading, or they were, the readings were at par with each other, equal values thi almost. However, the 5th panel tha, it has a not slightly, in fact, far much higher value. So there has to be reason why I'm getting a big value like this. And that was also not coming from all the portion of the panel. Actually, I placed the sensor on the 4 corners of the switchgear panel. At the top side only, I was getting these high values. However, on the bottom side, I was not getting these high values. So I could clearly say, yeah, the partial discharge is somewhere here, or something fishy is going down at the top, sir. Then they brought in their kit and they did the PD measurement again, and their kit also told the same thing. So it is just one facility that is provided by some manufacturers, but I would rather request you, or rather recommend you, to use your analytical technique, as we discussed earlier, that I've got 5 panels like the one I discussed. I will take measurement of all of them. If I don't have, let's say, if partial discharge was not there, I'll at least get a base value from that day, that, yeah, on this date, at this time, this was the value of partial discharge. Then again, if I come back after 6 months, I'll again check what is the value of, what is the value of signal that I'm getting. It can be partial discharge, it can be noise. That is a different scenario that we can do later. But and again, when you do it over the time, if anything fishy goes down there, or if anything wrong is there, you would easily be able to detect over the period of time. This is what I meant by doing the trending, which should be the right approach. So I hope I answered your question, Nitish sir. Then range for Jatinder Bhamra sir has asked, range for 220 kV GIS in offline. Sir, whatever, irrespective of the kV level, GIS always have 5 PC, sir. It should have a value less than 5 PC. Jatinder sir, I think you have something specific to ask, so I would recommend that we can discuss this separately. You have our contact detail. Do contact with me. If you have something specific, I'll definitely try to answer, sir. Now, Pawan Sharma sir has asked, can we check discharge in indoor 33 kV switchgear panel? Of course, sir. As I discussed earlier, you can easily do this. So NL camera is part of PD measurement and useful also for detecting partial. Yes, sir. I think I don't understand whether it is a statement or a question, but it has been answered. So Kamlesh Davande sir has asked, why not prefer PD test for LT switchgear? Sir, with LT switchgear panel, it is not like it is not preferred. As I told you, for anything greater than 3 kV, you can always use partial discharge testing. So if you are interested, we can do it at any given time. However, when it comes to, 440 or anything less than 3 kV, the kind of signal that you get, they are not actually, because in beginning itself, I told you it is a voltage dependent phenomenon. If voltage is quite less, it is not sufficient to energize these discharges to give out these waveforms or these waves that you can detect, these acoustic and electromagnetic waves. That's why it is not quite recommended to go below 3 kV. That is the only reason, nothing else. Now, Sandeep Lashkar sir has asked, PD test is done to check the health of insulation of equipment, correct? Or anything else? Of course, sir. Sandeep sir, what you said is absolutely correct. Whenever we are doing the partial discharge testing, we are always doing the insulation health monitoring or insulation diagnostics. Of course, you are absolutely correct, sir. Does DGA point to existence of PD? Yes, sir. If you, Narsimha sir has asked, does DGA point to existence of PC? Of course, sir. If you refer the dual triangle, they are at the very top of the dual triangles, which is one analytical method I believe you are very well aware of. It denotes the existence of partial discharges. If the ppm level of the gases, three of the gases, lies in that particular range. Apart from that, it is one thing. I think it is mentioned in one of the IEEE standards that if hydrogen is above a certain ppm, you should always go and check for partial discharges. So yes, it is DGA points to the existence of partial discharges. I believe I have answered the questions that were put forth on the chat box for me. However, if you guys have any particular question or anything, any subsequent follow-up, please do contact us. We would be more than happy to connect back with you.
Jayant, almost all the questions are covered, and we are dot on the time. So we are almost at the end of our 90 minutes. So before we close this particular session, I would like to just remind the participants about the next sessions that we are going to conduct. Of course, you will be getting the communications, the marketing communications from us. But since you are here, let me share with you what are the next topics in the pipeline. As far as this Substation Saturday series is concerned, the next one is going to take place on 10th of October. In the month of October, we are going to have 3 sessions. And the first one is on the Saturday 10th, and it is going to be on the underground cable fall location by using the scopes cable fall location products. So those, especially from the discom side or industries or maybe generation companies who are using the cables, this can be of great interest to them. Underground cable fall location using the scopes CFL series. The next one on the 17th of October is going to be on a control switching device for circuit breakers which are used for controlling the reactor or power transformer or capacitor bank. So the next one will be on the control switching device. The third will be on the third harmonic resistive leakage current measurement for the surge arresters. So a measurement typically called as LCM. So the next topic will be on LCM measurement for the surge arresters. These 3 will take place in October. In the month of November, we will have the first one on the dynamic contact resistance measurement for condition monitoring of HV and EHV circuit breakers. The next one will be on the primary current injection testing and the ideal kit selection, because there are a lot of confusions. What kind of kit we should select? Because there is a large bandwidth of the manufacturers when it comes to the primary injection kit. So that is the topic that will be dealt with. Then we will be having a session on SF6 handling products, SF6 gas handling plants or carts, SF6 gas analyzers, the leak detectors, etc. And the next one will be on transformer turns ratio measurement, that is the TTRM from scope. So these are the sessions which are lined up for the next quarter. You will keep on getting the communications from us about this. Now, this is as far as the Substation Saturdays is concerned. As you are aware, we are also parallelly conducting a webinar series for the users of our products. Exclusively for the users of the scope products, we are conducting a parallel webinars, which are more like the workshops for the users. And the next, this is taking place on Fridays, typically on second Friday, and these are taking place once in a month. So the next three sessions which are lined up on Friday, October 9th, that is on the previous day of the cable fault locator webinar. We have transformer turns ratio measurement with TTRM of scope. The next one in the month of November will be on LCM for the surge arresters, and the next one on the circuit breaker testing will be taking place in the month of December. So transformer turns ratio measurement, LCM for the surge arresters, and circuit breaker testing by using Scope's Hijack Ultima product range are the three next webinar workshops that are being conducted exclusively for the users of Scope products. So with this, Jayan, thank you very much for a wonderful presentation. And thank you very much, all of you, for being part of us. And we look forward to your continued participation. As you can see a flag there that do fill the feedback forms, especially if you have any special comments to mention with respect to the conduct of this particular program, anything which is related to the content, the style, the presentation, the timings or the days, you do give us a feedback, because that will help us improve the program and we are able to offer more value for the time that you are investing with us. So with this, thank you very much and have a very nice weekend. Thank you and bye-bye.